Welcome back to College Algebra videos. Today we'll focus on logarithmic functions. Specifically, our goals for the next two videos are to graph logarithmic functions more efficiently and determine the domain of logarithmic functions algebraically. In this particular video, we'll actually try to find a way to graph these more efficiently so that we can be faster. Last time, if you remember, we looked at the exponential function, used what we knew about the function, and then decided to graph the logarithmic. So today, we want to do it more efficiently, but we have to notice some patterns. So let's start with an example, something that you've seen before. So here we go. We have this function, log 5x, and last time what we did is we made a table. We made a table where we had x, and then we had 5 to the x. And then I told you plug in these numbers, -2, -1, 0, 1, and 2. And then when we plug them in, if you remember, 5 to the -2, well, now we know what this means. This means 1 over 5 squared, which is 1 over 25. 5 to the -1, now you know that means the reciprocal, so that's 1/5. 5 to the 0, you know means 1. 5 to the first, you know means 5. And 5 squared, you know means 25. And so if we try to graph this, what we would do is we try to plot these points, but we want the logarithm. We want the inverse. And so what I asked you guys to do last time is say, okay, here's x, here's log 5x. And now just take the inverses of all these. So the input would be 1/25, and the output would be -2. I'm just taking this first input and this first output and flipping them. Same thing here, I'll take this -1 and this 1/5, and if I flip them, I get that when the input is 1/5, the log of that would be -1. And when I take 0 and 1, so when the input is 1, the log of 1 should be 0. When I take the 5, the log of 5 should be 1. And then the log of 25 should be 2. And so when we plot this, we can't plot everything, obviously, but maybe this point, maybe not too difficult. This point might not be too difficult, and this. And in fact, when we graph logs, we usually focus on this area. These are the points that we like to graph because we sort of already know what this looks like. We know that we have 1, 0, so 1, 0 would be right here, somewhere around here. And 5, 1, 1, 2, 3, 4, this is 5, so 5, 1 would be about right there. And then if you remembered when you were in class, you knew that there was an asymptote right here. And then the other points are a little bit difficult to graph, but 1/5, -1, that's maybe down here somewhere. And then we just sort of connect. And it should look something like this. That's what the logarithm of 5x looks. Okay, well, the goal of this video is to get you to focus on this area. And so I want to show you some properties of logarithms that I want you to memorize, because if you have those memorized, then they'll work. But before we do that, let's go ahead and explore a little bit. So I want you to think about what we've done so far. The first time we had x and 2 to the x. And when we plugged in -1, we got 2 to the -1. When we plugged in, let's try this again. When we plugged in -2, we got 2 to the -2. When we plugged in -1, we got 2 to the -1. When we plugged in 0, we got 2 to the 0, which is 1. When we plugged in 1, we got 2 to the first, which is 2. And when we plugged in 2, we got 2 squared, which is 4. So when we look at the logs, when we flip, I always ask you to make a table, but I haven't really taught you to think about this in a symbolic manner. I've always said, oh, just take the element. 2 to the -2 goes to -2, 2 to the -1 goes to -1, 1 goes to 0, 2 goes to 1, 4 goes to 2. But what I want you to think is a little bit more symbolically. This column right here, here's what we're trying to tell you. This is sort of the key step. Okay, and actually this table, this whole table, this is what we're trying to tell you to do. We're saying, for example, let's look at the first row. We are saying that log 2, if the input is 2 to the -2, then the output is -2. In the second column, we're saying that if the input of the log is 2 to the negative 1, then the output should be negative 1. And so on and so forth. So this third one, we're saying that log 2 of 1, if the input is 1, the output is 0. And this next column is saying that the log 2 of 2 is equal to 1. And the last one is saying that the log 2 of 4 is equal to 2. We didn't do this last time because I didn't want to overwhelm you, but this is exactly what it is that we're saying. And in fact, we can do this for other powers. So for example, we just did the fifth one. So again, when we do this, we say, okay, here's my x, here's my 5 to the x, and here, let me just focus on the 0, 1, and 2. Okay, so 5 to the 0 you guys know is 1, 5 to the first you know is 5, 5 to the squared you guys know is 25. And so then we reverse everything. We say, oh, let the inputs be this. Now let's look at log 5 of x. And so now we reverse it, so the inputs now become 1, 5, and 5 squared. The outputs become 0, 1, and 2. But what we really want you to focus on is the following. This first one is saying that log 5 of 1 is 0. The input is the 1, the output is the 0. The second row is saying that log 5, when the input is 5, the output is 1. And this last one is saying log 5 of 5 squared is equal to 2. Now, look at these two examples. Oops, let me see if I can bring them in. Look at these two examples, compare them, and notice that there are some patterns here. There are some really nice patterns. In fact, one of the nicest patterns is actually here. When I plugged in 1, whether I plugged it into the log base 5 or the log base 1, I got 0. And then the other nice pattern is that when I plugged in the actual base, I got 1. And these should be things that you've seen before in high school. And so how does that help us? Well, there is this nice little pattern. And this is what we'd like you to memorize. If you can memorize at least these two, but try to memorize all of them, this will make your graphing experiences much, much easier. And so let me give you an example of how this would help. Let's say, so how does this help me out? So let's see. So one of the things that I like to, let's say I'm not very good at this, but let's say, notice that the 1, I know something about 1, so let me try to plug in 0 first, g of 0. Okay, what that means, this is my input, the 0. What that means is that what I should do is I should do 2 times log 3. I should plug in the 0 for x, and then do this. Okay, well that means I have 2 log 3 of 1 minus 3. But now you should know, or at least this is what I want you to memorize, is that the log 3 of 1 is actually 0. This is from the previous slide. Anytime you plug in 1 into any log, regardless of what base, regardless of the base, it should always be 0. And so this is minus 3. And so here I get a negative 3. Okay, not a problem. This is good. Okay, so what about g of 1? Well, g of 1 I'm not going to be too sure because it's going to be log 3 of 2. So if I plug in, let me write this here. If I plug in 1 for x, I'm going to get a 2 here. That's not going to be very helpful. But if I plug in a 2, I get a 3, and this is a good thing. And so let me go over this. So let me plug in 2 in here. And so that means I do 2 times log 3, and then my input is 2, so I should replace the x with 2, plus 1 minus 3, and let me scroll up a little bit. Okay, well, what does this give me? Well, this gives me 2 log 3, and then this is a 3 minus 3, and then from the previous slide we know that when the input matches the base, we should get 1. And so this is 2 times 1 minus 3. And so you guys know that 2 minus 3 is negative 1, and so we get this. And so now hopefully you can put everything together. You remember hopefully that this represents a shift to the left, shift left 1. And the reason I say that is because hopefully you remember there's an asymptote, and so the asymptote shifts left 1, and so here goes the first asymptote. There it is. And then now I have a couple of points. I have that when the input is 0, the output's -3. So the input is 0, the output's -3. That's about right here. And I have that when the input is 2, the output's -1. So I go to 2 and go to -1. And I know the shape of the graph. We've done this quite a bit. So I know that this graph looks sort of like this. And that's enough for most of the things that we want. If you know this, this would be enough, and most professors would be happy that you can do this. Okay, this video is getting a little long, so I'll stop here. In the next video, I'll do a couple more examples, and then we'll go over how to find the domains algebraically.